number of these little dots is messed up. It's 13 times 13 times 13, 35 times. So it's negative 13 to 36.
Oh, those are
So it just looks funny.
It's over 35, not over 35.
No, it's not over 35. That means 35 times. So it's times in numbers in math.
So would it be 13 to the negative 35 or negative 13 to 35?
Yeah, negative 13. Negative 35 is that, dividing. This is talking about negative 13 times negative 13 times negative 13 times negative 13 times negative 13.
Which means the answer would be a negative or a positive.
Negative, because it's a odd number.
There we go.
Hey.
Alright, sorry.
Okay, I appreciate it. But, I should have told you every time.
Oh, I know.
Hey, we're collaborating. Almost feel like exit tickets should be a collaborative process rather than an independent measure.
If you want only a couple of kids' thoughts on paper, that's great. If you want every individual kid's thought on paper, that's a good idea. I'll just start though. We talked about this, right? Is to start, you want to like give the kids.
Nobody knows everything, but everybody together knows everything. You know what I'm saying?
But if you're taught it, it's different. Because like if you were to teach a lesson, I could do the exit ticket on my own. But yeah, if you're just going to give me an exit ticket and expect me to do it, like then I would like to use collaboration.
Yeah, that's true.
But in class we're teaching it, so we're expecting them to understand it.
They talk and I can't talk. But this sometimes exit ticket is confusing. Like the first problem is confusing.
What's the expectation for like?
Now you got it.
Miss Trans over there knocking it out the park. Everybody else is cheating. She's over here like writing a full page paper. Look at that.
Like, what's the expectation for like an explanation in math? Like,
A sentence.
I'm not gonna go.
Okay.
A sentence is
A
just
sentence motion.
We're gonna all get to this. Get that. Ms. Pineda had a great point. Ms. Tran has a great point. Finish the exit ticket and then we get all of that.
I go on these coffee chats with a friend who's like, getting a PhD in math, and he'll be explaining things like simple addition with a page-long proof.
Cool. Look at the last show that we won. Think about that.
I'm not sure about the last one actually.
Think about this.
Okay.
Okay.
You just put it on there. Do we want to start a timer? I need a new timer too.
Oh wait, so
Is it not parentheses or is there? I don't remember that.
I just think it's fun.
so I wrote it wrong again.
No, that's right.
Yeah, what are you taking negative from?
We could.
It's an odds though, but if it was an even exponent, you could have probably just removed the negative sign, but since it's an odd exponent, you would take it. I don't know, I think so.
One more minute.
Talking and one's gonna go on the board.
Oh, it's on you for it now. I gave you one answer. So no.
When that time goes on, we do stop it.
That's not on. Right, this thing is.
So you pointed that out.
I need this. I'm about to take that.
Yeah, but
Lots of details.
what's wrong with you?
Mine makes like weird noise, like.
know in order to master this like standard skill, and then what they have to show, and I put parentheses around show their thinking. And so when you took this exit ticket, what were some of the things that you think an exemplar, that's what I want to do, is create an exemplar that can be like 2 or 3 things that the kids need to know in order to complete this exit ticket well, that match with the standard. What do they have to know? What do they have to know in order to do well on this
To
exit
do
ticket?
this, well, they have to know that's not a division problem, first of all. They need to know like how Engage is presenting problems, which is one of the big challenges we have, is how problems are presented differently within the context of Engage, the context of SBAC, the context of ANET. They're all different frameworks and ways of presenting problems.
So you thought that was
Different
-13
notation.
divided by.
I thought it was like divided by 35 times. I was trying to figure out what the hell it's talking about. Because it looks like a division.
Like Ms. Pineda was saying though, during the lesson, I'm sure you guys put that, or did you, does Engage show it
It
in
was
this
like this in
format?
the lesson, yeah, it was. And I explained it to students how it looks weird the first time.
And then one of the things we want to do moving forward, right, Mr. T and I talked about this, is grabbing problems from SBAC interims and SBAC, the website or whatever, and then putting them into our exit tickets, so that the kids kind of like get used to seeing the format that SBAC is. Because the format is one thing, but the skill is it's the same. So once you got past that, what else did you get to know in order to
How to
do
do
well in this?
negative and positive numbers. So you need to know negative times negative. Positive.
The odd amount of negatives will result in a negative product, and even amount of negatives will
Positive
result in a
rules.
positive product.
Rules. Yes, they have to know the rules.
Are they loud?
No, those are rules.
Rules?
No?
Seems like a lot of me. I don't know.
To me, they're like patterns.
Is it ever going to change? No.
Pattern rules.
Hence.
It's a law.
They do have to know the law of exponents. Good. Now, what did they have to show?
Exponential notation.
For this, I heard something very telling just now. For the pattern rules, law of exponents, what did they have to show? In the second problem.
They have to show that they understand the relationship between exponents and repeated multiplication or repeated division. They needed to know what the vocabulary of times.
Hold on, go back.
Sorry.
They had to understand,
They understand.
sorry.
The relationship between exponents and repeated multiplication and or division.
And somebody said the rule. I heard somebody say it.
That's just a negative.
It's odd.
Odd numbers.
Negative. Positive.
Positive, yeah.
Okay. All right. Will you pass out my exemplar, please, Mr. Teacher? Now, I worked through an exemplar. And see if you can see if you agree with my shows on here. And what's different between my show and what's different between my show and maybe you can be a little bit specific in what we listed here that you put for your shows? Anything jump out at you?
Well, first of all, you put parentheses around your number, which I did not, and I'm not sure how that affects the final answer.
Well,
Whether
then,
that changes
so
its value or not.
three, we
No,
didn't
for
So
talk
like
about
negative
one.
13 to 35,
Right.
you put
Oh,
that
parentheses
is
around negative
correct.
13, does that change its value if you don't? Does
No, it
change
doesn't, but the law is that you're supposed to, law.
If it's
The
34.
The suggestion is that you need to put parentheses around negative numbers and fractions. So that's why number 3 is incorrect.
What's
Because
the
it's no-
purpose for that though? Just for
So
separating it for the
next
number
step
to
or
help you
whatever.
focus in that there's a negative sign here?
Yeah,
Just
it's
So you know it's negative.
it's closing in a quantity, it's all it is really.
So,
But yeah, sometimes doing that changes the outcome of a problem, whereas if you're doing it
it doesn't
It
change. the
doesn't.
outcome.
Here.
without changing the outcome, then you need to be clear about, okay, why are we doing it in this circumstance compared to why are we doing it in this circumstance? In one circumstance, you're changing the actual outcome of the product or quotient or whatever, or the expression. In another circumstance, you're just trying to help the mathematician kind of see this, focus in on the negative sign or the fraction sign and kind of separate the values from the other values, which are two different groups. And probably hard to.
Always a good idea to put negatives, parentheses around it. It doesn't change anything.
Okay.
Unless it's like a.
The kids are going to be doing scientific notation next, and understanding that process is very, very important. Anything else jump out at you?
On the B part, the positive negative part, you kind of wrote out the difference between a negative outcome and a positive outcome based on the amount of negative 13s that are
Demonstrating a pattern,
right.
like an underlying pattern.
Which would be kind of cool to do on a regular basis, not just on this exit ticket, but have them practice writing that rule or law, whatever we feel like calling it.
So what do we do?
Focusing on
What do we do
different
typically in a math
problems.
class? Positive.
Right.
Uh,
Positive is
What?
positive.
Now, even, positive, odd, negative.
Right.
Say it again. Odd, positive, whatever. Positive, odd, even, negative, whatever. We do that, right?
Right.
That's what you do.
And then the kids they know the step really well, but they have absolutely no idea what the rule is saying. So I did that on purpose to show my thinking that I understood that if you have a series of negative numbers, if that series is odd, then if I go through the process, it's going to be a negative number, and that's true all the time. Then I can say, oh, I see it, it's odd, I don't have to go through that all the time.
And also, like
I
how in
get that.
one example you use numbers and the other one you use variables to develop algebraic thinking and stuff
Sure.
like that. You know.
I was demonstrating a pattern, right? And I was showing what I was thinking. That's very important. So let's look at the student example.
My question is this, for the last one,
Yeah, you didn't put yes or no.
I put yes and no. So, no, because this is my question. So if it's negative 3.1 to the 4th power, can I write that as negative 3.1 to the 4th power, but if I wrote it as an equivalence, that equivalent should be positive? Or do I need to, at that point, remove the negative to be accurate? Like, is his notation correct if he writes negative 3.1 to the 4th power? Because technically, because it's to the 4th power, it's eventually going to be a positive number. So does that mean?
But it's a negative number, man, so.
No, it's a negative number, but, no, right.
I know it's
right.
gonna be positive, but you're not multiplying 3.1, you're multiplying negative 3.1 times negative 3.1.
Right, so-
Times negative 3.1 times negative 3.1. So the difference
So you
between.
would include the negative, but if you were asked to write an equivalent value, then that value should be positive. Okay, I wasn't sure about that actually. It's kind of like almost semantics, but.
Negative 3.1 times.
No, yeah, I get what you're saying.
You
The
get what he's
final
saying?
product would be
The final product would be
but
positive.
But that doesn't matter,
So
because
if they
you're
just,
multiplying by negative, you're still multiplying by a negative number.
no, but,
So 2 times 2 is 4,
Right.
but at the same time, negative 2 times negative 2.
no, I got you. So if you're grading this and they left the negative off, would you mark them wrong?
Yes.
Yeah, but it's not about the negative, it's about the parentheses.
Okay.
And the negative is, you can't just say, oh, it's 3.1 and negative 3.1 are the same thing. They're not the same thing.
Well, negative
You're
3.1 to the
multiplying.
fourth power and 3.1 to the fourth power equal exactly the same thing.
Exactly, but you're not doing the
So-
same thing. You're multiplying 3.4.
So technically,
Exactly.
well, not,
You're not doing the
But
same.
you're multiplying
but
negative 3.1
Later-
times negative
later it's very
3.1
important.
times negative 3.1
I see what you're saying.
times
However,
negative
that's an
3.1.
equal sign, and that equal sign is only asking that you place an equivalent value on the opposite
All right,
side.
But having
all right,
negative
we
$3
can,
and
hey,
positive
we
$3
can go
right.
all day, we can go all day, we can go all day. We're gonna stop that
No,
conversation.
that's it. All right.
Let's continue now, please, because we do have time. I want to honor everybody's time. And look at the student examples and the things that we circled over here, showing their thinking and looking at the exemplar to compare these. I want you to do that and take a quick minute and see if you can list what the kids missed in this exit ticket. Because we're going to look at a key misconception.
It's cold in there, right?
Freezing.
How did I go get 1 out of it? You just got
Oh, so one was, technically he got one wrong because it's one A and B. So he only got this one wrong, technically. I mean, this one right. Technically, we only got this one
So
right.
you can only get full credit from this, or credit from this.
I wouldn't want to do that one. I mean, I could have, like, sometimes I put a 2 out of 3 if they were close. But, like, that was a big part for him. And
She has a couple, so let's let Megan see
Okay,
what she can come up with a
Listen to this
misconception.
too. Hey, so let's see.
I want some.
We're diving into the standard
So
though.
that's what I'm saying though, so you mark this one,
Don't worry about how he marked it. I just want to know what the misconceptions are. We're not talking about kids' grades here. We're talking about what do you think the kids missed with this compared to what we are talking about, showing their thinking and demonstrating a pattern. You can talk about the grading later.
well, no, so I'm talking about number 3. So if they put parentheses, it's correct, and if they don't put parentheses, it mathematically means exactly the same thing. So you're teaching them this rule
It
of
doesn't.
putting parentheses.
Let me
Mathematically,
stop.
It does.
Let me talk.
Okay.
It doesn't because the parentheses is what they're doing. It's how they're doing the problem. Yes, you come out to the exact same thing, but later when they do scientific notation, later when they do distributive property, those
Right.
parentheses around the negative are very, very important.
Right, no, exactly, when it becomes important, but in this scenario, you're teaching them to do parentheses outside of that context.
But
Which
but
may
it's
be
okay because then
confusing.
they get used to it, the process. So
it's
let's
just-
talk about the
so it's just
parentheses
about- okay.
later. Let's talk about more showing their thinking and are they demonstrating a pattern and showing their thinking in the answers that they give. And this is post grading.
So the ones I'm looking at tend to be really focused on the parentheses rather than any other outcomes of this exit ticket. Those are just the ones I'm looking at. So it's like parentheses,
The grading is, but
parentheses.
again, I'm not talking about the grading.
all
I'm
these-
talking about what the kids are answering, how the kids are answering the
Well,
problems.
well, yeah, they're demonstrating their understanding of the necessity to use parentheses around the base number
That's a quick
to
fix.
separate it.
That's a quick fix. Mr. T can
And they
quick
got
fix
that
that.
down, yeah.
Yeah, they got it done.
Something I had to do?
Yeah. Kids can learn negative, exponents, parentheses. That's easy. Quick fix.
I felt like a lot of them got that. Like me and this train got ones where
Yeah.
that was correct. I don't know which one you got, but it's
No, that's good.
All right.
all right, time.
Anything else? I'm looking at something big. What are you talking about? How many kids showed their thinking?
They just wrote the rule.
They wrote the rule, right?
Mitchell wrote the thinking kind of.
What do you write?
The wrong way.
The product will be positive because there's 2 negatives, so he probably went the farthest.
But he didn't understand. See, Mitchell didn't understand that he was doing this.
Right.
Mitchell, like this.
Just saw.
Mitchell saw positive, negative, referred back to a rule that he knows because he's been drilled it. If you have a positive and negative, it equals a negative. End of story. So he showed his thinking, but it was the wrong thinking.
Right.
Right?
But he showed an understanding of the rule, but he misapplied it.
He misapplied the rule. Exactly.
Because of just a different context that he's not used to.
Another reason why it's so important to teach the kids the concept, right? So they can like show. So I would think that can we agree that this is the misconception for this? I think a key misconception. And so I'm going to call these new teaches instead of reteaches. Mac, you mentioned it before. What would be a good way forward for Mr. T to have the kids show their, because they're going to ask this all the time, show their thinking and demonstrate a pattern? Is that a modeling lesson, or is it a
Jonah Mora to the front office, please. Jonah
So
Mora
I
to
would
the
just
front
steal
office.
your little example template right here and have them use it, consistently on projects, right? Show them this, teach them this, and have them use it on every problem.
would that be modeling or guided discourse?
Both. At first, it's going to be modeling, and then it needs to transition into guided discourse.
If that's
Have a
true,
conversation
if that's
around
true,
it.
then it's a guided discourse lesson. Modeling is like, I want a specific thing, and I'm going to show you exactly how I want it, and I want you to show me, and that's the end of the lesson. Guided discourse is I'm going to show you, and then I want you to work through it. That's more like guided discourse. I would agree with that. All right? So let's give Mr. T some examples. Well, no, what are the examples? Not props yet.
I thought I was getting praised, man.
What would this guided discourse look like? That's the question.
I can't answer, right?
Huh? Yeah, you can answer.
Oh, okay.
What would this look like? Let's take a few minutes and write down how you would say, Mr. T, maybe you should do this. And then we'll be, oh, that clock is wrong there.
First one getting fried this week.
We have about 7 minutes left.
We're writing this down, or we're saying?
Yeah, we can write it down or just jot it down, and then we're going to give Mr. T some guidance. That could be true for a lesson in the future.
I would say take this, and anytime they're working on stuff concerning exponential notation, whatever, they write this at the top of their packet. If they're doing a test, write it at the top of their scratch paper. Just have them put this down for referencing.
I feel like that's more of a memorization of the rules, though. It's not like understanding and seeing the pattern.
We're talking about.
Yeah.
Oh, so.
Top this one.
I understand what she's saying. I don't know if Canada did this, so I seen one kid do it, so props to you. At the top of the paper, they wrote negative, positive, and then negative, and I think they got that from you. It was great. And I understand what you're saying, Mac. But I think when we're talking about probably the guided discourse, where maybe the first 2 weeks, and I might do this, is go over the exit tickets. Because when we talk about the misconception, might just be engaged New York and being used to it. I mean, and used to how things are written out and that kind of thing. And so going through it, and then circling, like annotating, and that says circle explain, right? And then having the students, if you talk about guided discourse and not modeling, have them write one complete sentence or 2 complete sentences on why this product will be negative or positive. So that's what I thought of. So now the next time they know, when it says explain, because that's the one thing every kid did not do, besides maybe Mitchell or 2 other kids, is they did not explain. So circling that and showing them that explain means that you're writing 1 or 2 sentences in math. Like you need to explain and show your thinking the rule, and then doing that together until they're able to do it by themselves. Same thing with number 3, why or why not. Doesn't just mean you put parentheses. You should probably have 1 or 2 completed sentences.
I had like this trouble too, but like explaining things in math,